Okay, good afternoon, class. We are going to be learning about the solar electrical panels. And the first thing that you have to understand is that the panels, solar panels, convert the solar energy into DC. The panels are made up by small cells, photosensitive, that when the sunlight hit them, they produce, each of them is able to produce half volt. And they are connected in series. So for example, this panel, I will show you right now, is able to produce 20 volts DC. So I will connect the high intensity discharge lamp to be able to simulate the solar energy at 12 p.m. So right here, I should be able to, I need help one of hold it so they can see. So I will be checking the DC, okay, right now, and I should have around 20 volts DC. We need to select the proper scale, which is DC. Turn on the lamp. Okay. Yeah, right now it's producing 18.6 volts DC. Okay, but of course, we cannot use this DC energy in a dwelling unit, house or apartment. So we need to convert this energy into AC, alternating current, which is 120 volt AC, correct. Let me disconnect this because I need to be working. The other source of DC that we have is the batteries. Okay, the batteries are able to produce DC. They have, after a chemical process, they produce DC volts. Okay, in this case, the same like solar panels, I have a DC, but I cannot use the DC into any appliance in a dwelling unit, house or apartment. So I need to convert the DC into AC, okay, alternating current. So how do I do this? I use an electrical device known as inverter. The inverter get the DC, okay, and convert it into AC. So in this case, this inverter is able to produce 3,000 watts, and the output, the input is 26 volts DC. The output is 120 volt AC, okay, 3,000 watts. And because the majority of the batteries come in 12 volts, I need to connect 3 batteries in a series circuit. So 12 plus 12 plus 12 to have here 36 volts. Let me check that we have 26 volts DC. So at the input of the inverter, when it's DC, the red one is the positive, the ground, the negative is black. So when I have this, and that is the standard, so I should have 38 volts, okay? 38 volts DC. But again, I cannot use this to, in a kitchen, for example, to power up and use appliances. I need to convert this energy into AC. then I need the inverter. So the batteries come in three popular sizes: 12 volts, 24 volts, and 36 volts, okay? And the other characteristic is the amperes. So this battery, for example, this battery is able to produce 6.1, 6.3 amperes, okay? These three, the same, 12 volts. So I have connected this in a series circuit. The positive is going to the negative, the positive to the negative, the positive is coming here, and the negative from this end is coming to the negative of the inverter. There are two types of inverters. There are inverters that work with solar panels, okay, and batteries, and convert from either source AC, okay. And there are other inverters like this one that work with the batteries, get the DC from the batteries, the battery bank, and convert the battery DC into AC. And of course, we can connect the solar panel here, but in this case, the solar panel will be used just to recharge the batteries when we are not using the batteries, okay? So that is one format. The other format is inverters, and you will have one of those that is able to get solar energy, DC, like this one, and directly convert it into AC, or the batteries, or both of them. So in this case, if I turn on this, so it's getting 36 volts, and it will be giving me 120. Okay, so if I check the output, we need to switch the scale to AC. If I check the output, I have 120 volts AC. Okay, how long I can use this power? Depending on the battery size. We are going to determine that. So if I turn on my disconnect, okay, I will be able to convert, and you will see the conversion process, DC into AC. Got it? So, and I can connect a motor. This is able to provide me 3,000 watts. Okay, 3,000 watts. And I can light up and power some appliances. Okay, how long? It will depend on the size of the batteries. How many minutes? 8. Okay, so how do I determine my battery size? So, first of all, I need to know that battery is 6.1 amps. Okay, and they are connected in a series circuit, but each of them is 6.1 amps. And this unit, this device is converting the energy. Is converting the energy. In this case, DC into AC. What is the multiplier? How do I know that? The factor. On the inverter, what I have is 120 volt AC divided by the input, which is 36 volts DC. So this is giving me a factor. This factor is used to multiply the energy at the input times the factor is giving me the energy at the output. In this case, it's 3.3. That is my factor. Got it? So if I have, right here 6.1 amps, my battery, okay, and my factor is 3.3. That will be giving me the amperes at the output. That will be providing me my inverter, which is 18.6. Okay, that is the factor. The next question is, how many hours do I want to have this? So I say, okay, 2 hours every night. So I will have 18.6 times 2 hours. That will be giving me 16. So that is if I want for 2 hours, okay? That is what I need here in my bank. So the next question, this was the number of hours. For how many days? Let's say 3 days, 3 nights. Without using the solar panel to recharge this. This is the way that it is, okay, right here. So I will multiply 37.2 amperes per hour times 3 days. This number of days is known as autonomy. The days of autonomy that my system, my electrical system in my house or apartment is able to work just with the batteries. Got it? So if I multiply this, I hope I won't make a mistake here. 6, 21, 9. That will be the size of my bank, battery bank. So my battery bank should be producing this amount of ampere per hour, okay, for the 3 days. Okay, so that is the way that you determine the size of your bank, battery bank. Of course, here, the next step will be connect my solar panels. To do what? To recharge this. When? During daytime. Okay, so at the end of the day, during the sunset, the batteries will be recharged. Okay. In the way that it is, after 3 days, so that is what I want. Most probably the battery will be completely discharged. So I need to connect in parallel my solar panels right here. But in order to protect my battery, the next step will be using a charge controller. So the solar panel will be connected to the charge controller, okay, right here. And from the next, the batteries. To do this, I will avoid to overcharge the batteries. And if I overcharge the battery, they will explode. So, and most probably a bank like this one will be charging 1-2 hours. The rest of the hours, the battery, the solar panel will continue producing energy, but it won't affect this. So, if that is the case, in my service panel, I have to have a special meter, bidirectional meter. When my solar panels are producing energy that I am not using, it could be sold to the service company. Or part of the energy is used to recharge the battery, the other part will be to sold and pay in advance the energy that this facility could be using. How many minutes? Okay, so that is the first video. This is the tier lab. The students, this is a demo for the instructors, so you have to be careful when you install this, the polarity, okay? So positive to negative, positive to negative, positive is coming to the battery, okay? And respect the color code. Very important. On DC, the black one is not the hot line. The black one is the negative. The black one is the negative, okay? It's not the hot line. The positive is the red one, okay? So you have to be careful. When you connect this, you have to connect, first of all, the negative, okay? And then be careful, you connect the positive, and the inverter should be off.